Okay, so
we gotta do number.
are we good with number 3 then? So we started out with this. We took the derivative to get velocity. We took the derivative to get acceleration. Plugged in 4.5 and got that the acceleration is actually 0. Are we okay with that? Okay. So what are we doing now?
I have a
4.
question.
Number 4. Okay. What's your question, Lindsay?
Is number 6 8?
I don't know. I don't have an answer key. So I'll have to do it. Well, let's do number 4 first. All right, so number 4, we'll have to come up with an equation for a line. We already have a point, so all we need is what? Slope. We can find the slope by taking the derivative. So we have to do quotient rule here, right? So that is low.
You did it the other way around.
How would you do that? Like make it, put the x plus 1 up to the negative 1 or something? Yeah, I guess you could rewrite it as x to the 1/2 times x plus 1 to the negative 1 if you wanted to, and go product rule. Either way would be fine. This won't be so bad though. So we're going to go low d high minus high d low over the square of what's below. Right? The 18?
Yeah.
Now what?
X.
What's x? 9. So I'm going to plug in 9. So 9 plus 1 is 10 times 1/2 times,
1/3.
yeah, 9 to the negative 1/2 is 1/3 because 9 to the 1/2 is 3. And since it's negative 1/2, it's 1 over 3. Minus the square root of 9 is 3. All over 9 plus 1 squared, which is 100. So what's 10 times 1/2 times 1/3? 10 sixths.
5.
What's that?
5.
Okay, so 10 sixths reduces to 5/3 minus 3 over 100. Bogged down in 6th grade math here in calculus class.
Negative 4/3.
Negative 4/3 because this is really 9/3. So 5/3 minus 9/3 is negative 4/3 over 100. Is negative 4 over 300, right? Because you multiply by the reciprocal, so you multiply by 1 over 100. Which is negative 2 over 150, which is negative 1 over 75. Is that what that works out to?
Yeah.
So that's the slope, right? But we're supposed to come up with the equation for the line, and I'm trusting that you can do that last part yourself. That's the easy part. Y minus 0.3 equals negative 1/75 times x minus 9. Or you can use a decimal. Negative point, what do you say?
Negative 0.012.
So why would you do that? That's what you're doing.
Because it's negative. Maybe you should just sit down and have a heart-to-heart with him. Hug it out. Get over it. Okay, now what? 6? 5? You got 5 before. 5 is on a quiz.
Gotta do all of them.
Oh, we gotta do all of
I'm
them?
on the quiz.
Yeah, pretty sure. Okay, so first thing I rewrote the square roots as fractions, of course. What derivative rule do I have to use to get this going? What'd you say, Shep? Product rule. So walk me through that. So you're going to go the derivative of the first one times the second plus first one left alone times the derivative of the second. This is where things get a little bit sticky. you have to do the derivative of cosine first. So this is in parentheses, so we're going to do the chain rule. So we're going to go outside, in. So the derivative of cosine is negative sine. Leave this the same. And then multiply by the derivative of the stuff inside the parentheses. So it looks like that.
No, no.
Yeah, you're done. There's some really easy simplifying you can do. The x to the 1/2 and the x to the negative 1/2 will cancel, but you know, yeah, not. Okay. All right, number 6. So the mass of the part of the metal rod that lies between its left endpoint and a point x units to the right is 4x squared. Find its linear density when x equals 1 meter, and Linnea, the answer is yes. The answer is 8. Because what do you always do first?
Derivative.
Take the derivative. 8x. Plug in 1. That's it. Easy money.
Oh yeah. Number 7.
Okay. All right, number 7, our old friend linear approximation.
You already saw this.
Yeah.
Why do you take the derivative?
Because that's how you find the linear density. If you wanted the average linear density, then you'd compare the left to the, you'd go like a y2 minus y1 over x2 minus x1. But if you want the linear density at that particular point, that's like the rate of change of the density at that point. You just take the derivative and plug in the thing. Pretty dumb. When in doubt, take the derivative, plug it in. Good chance you're right. Why? I don't know. They explain it in the book. They have a big long, just because it's the rate of change of the. Okay, so let's see if we can't figure out this linear approximation thing. So what do we do first? What's that? What do you mean by the original? Yeah, so the first part of our linear approximation formula is take 0 and plug it into here. And what do you get? 3. Okay, so that's f of a. So that's the first thing you have to do. Take a and plug it into there. Plus, now we're going to take the derivative. That, you would have gotten that one on your own, right? Everybody would have remembered to multiply by -1? Okay. And then we need to plug in a for that. So what do you get from that? -1/6? Yeah. So that means my slope is -1/6, so that comes next. And then it's x minus the a, which is 0. So my linear density, or my linear approximation formula for this is 3 minus 1/6 x. So this guy right here is y2. Okay, this thing right here is y. Oh, I should probably call that y1. So we're just doing the exact same straight line formula as we did on this problem right here. Y minus y1 equals the slope times x minus x1. Okay? So this is the y, this is the y1. All they do is they solve it for y by putting it on this side. This is the slope. This is your x, obviously, and this is the x1. So it's the exact same thing as the point slope form that you've been using for a couple years now.
That's right. Why'd you put the 3 minus 1, 6x minus x? What is that?
Because I just simplified this. X minus 0 is just x, and plus a minus 1 6 is just minus 1 6. So this is an easier form of this right here.
Negative 1 is zero.
Yeah, because you have to take this and multiply it by the derivative of the stuff inside the parentheses. And the derivative of 9 minus x is negative 1. Okay? So if this is my starting formula and I want to use it to figure out the square root of 9.09, the question is, what does x equal? 0.09. But if I plug 0.09 in here for x, then I won't get the square root of 9.09. I'll get the square root of 8.91 or something. So negative 0.09. Because then 9 minus the negative, right, that'll make it a positive. So then all I have to do is just plug that into there. So that. What is it? Oh, I know how that works. Because this negative and this negative cancel each other out? So this is plus that? Oh, well, that's even easier then. So my approximation is going to be 3 and 3/200ths, which if I multiply that by 5 to get to 1,000, that'll be 3.015.
Oh, yeah.
Okay. Did it in my head, no calculator, just approximated the square root of 9.09. How cool is that? Pretty impressive and super useful. Can't tell you the number of times I need to approximate a decimal square root and I don't have my calculator. I can't tell you right now. Because the answer is 0. I can't tell you. Too fast? You need me to go back?
Oh, yeah.
And that was Johanna that called and asked me to record for her and Matthew and Casey. So this will be online tonight. So if you want to rewatch it and try to figure out what the heck I'm talking about. And good luck with that. All right, number 8, word problem. 2 cars start moving from the same point. One travels south. At 28 miles an hour. So what were we just told? The derivative of what? Dy dt. And that is 28. The other travels west at 70 miles an hour. So this is dx dt equals 7. Okay. What rate is the distance between the cars increasing 5 hours later?
So it's going east.
Oh, it says going east?
It don't matter.
Oh, he's going east on the board.
Who cares?
It's going to be, you're going to be okay? All right. So 5 hours later, what is this distance?
350.
350. What is this distance? 5 hours later? 140. And what is this distance 5 hours later? Nobody.
377.
You rounded it? Okay. So yeah, you take the Pythagorean theorem, take the derivative, and then you can cancel all the 2's, right? So we basically have our Pythagorean theorem derivative as x dx dt plus y dy dt equals z dt. So plug in stuff, blah, 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 blah. So then you plug everything in and you get 75.
Just take the Pythagorean theorem and get 75. Is that it?
Now if you plug in 350 for x, 70 for dx dt, 140 for y, 28 for
Yeah, also if you do 70 squared. plus
Oh,
28 squared.
with the rates?
70, yeah, 70 squared plus 28.
Not true.
Oh yeah,
No.
that's temperature on that line.
It's a lie.
Oh no.
Rounded to the near, oh, it said rounded to the nearest hundredth on the problem? Okay. So you got 75 point what?
38.
38. Now, if it said rounded to the nearest hundredth of the problem, we probably should have had this to the nearest hundredth too, but that's okay.
I'm real close.
Shh. It's not true, it's not a thing. That's just, that's heat. All right, number 9, baseball diamond. We've done this one before, right?
Nope.
Okay, so there's my baseball diamond, 90 feet on each side. A batter hits the ball and runs towards first base. So they're running this way with the speed of 26 feet per second. So dx dt equals 26, and we're going to make this distance right here be x. At what rate is the distance from second base decreasing? So we're going to find this right here. And he's halfway to first base. So I know that you want to plug in 45 right away for that, but we need to do the Pythagorean theorem derivative first before you start plugging in numbers. So this side right here I'm going to call y. This side right here is 90 minus x, and this side right here is z. Okay? Yeah, because the whole distance is 90 feet, and this distance that they are from home plate is x, because that's the rate that they gave us, that this was increasing at 26 feet per second or whatever, so we have to use that as x. And we got a right angle right there. So 90 minus x squared plus y squared equals z squared. I'm trying to use your secret formula now. Because it's changing, so when we take the derivative, we need to use the variables first. So you always come up with a formula first, take the derivative, and then plug in the numbers. If you just plug in 45, no, because then the derivative of that would just be 0, and then your dx dt would just totally be lost. So you would never even use that piece of information there. So how do you take the derivative of this? Can't do it?
2.
2.
90 minus x plus
No, because he's just doing the power rule first. So remember, you only take the derivative of one thing at a time. So the first thing he's doing is taking the derivative of the exponent, and now he's going to multiply that by the derivative of the second side, which is negative 1 dx dt plus
2y
2y dy dt
equals 2z.
to the,
And cancel the twos.
okay, cancel all the 2's. What else? What's BYD? We don't have that on our screen anywhere. Zero, because the distance between first and second base isn't changing, so that whole thing cancels. And then now, Ben, we can put in the 45 for X. So 90 minus 45 is 45. I'm thinking 1 is negative 45. Dx dt is 26. Did anybody do the Pythagorean theorem and figure out what z is at the instant when this is 45 and this is 90? 100.6. 45 root 2 or something. Multiply those together, divide by 100.6. What is it?
11.63.
Okay. Okay, I'm going to skip 10. We're going to come back to it if we have time. That's what you want to see. Yeah, it's a little bit crazier than ones that we've done before. We'll try it. Not if you don't have time to come back and do it. We might have time. We'll see. Could be lucky. All right, two sides of a triangle are 2 meters and 3 meters in length. So here is 2 meters and here is 3 meters. And the angle between them is increasing at a rate of 0.03 radians per second. So d theta dt equals 0.03. Okay? All right, find the rate at which the area of the triangle is increasing when the angle between the sides is fixed length pi over 3. So we're not going to plug that in yet. We're going to come up with the formula first, take the derivative, and then plug that in. So what's the formula for the area of a triangle? Do you remember that has the angle in there instead of the altitude, not the 1/2 base times height? Do you remember that? We did it last year, Shad. It's in our book. Not Heron's formula with the semi-perimeter, but okay, so 1/2 AB sine theta is the formula that we're going to use for the area in this case. Nice job there, Nate. So I have to take the derivative. And this is a little bit tricky of a derivative because I have a bunch of variables. I guess it's not actually because this is A and this is B, right? And those aren't changing. So when I take the derivative of this, I can just pretend that those are a constant. Okay? So I'm going to go 1/2 AB, and then all I have to do is multiply by the derivative of sine theta, which is cosine theta. And then since we're talking about rate of change, I have to go d theta dt. You sure you don't want to go back and do tangent? That's a good one. Similar triangles. Okay. All right, and then all you have to do is just plug in all the stuff that they give you, and then what you get is your answer. So as long as you know this formula right here, that's not really that bad of a problem.
Basically,
Yeah. So 1/2 times 3 times 2 times cosine of, what was it, power 3 times 0.03. To that, what do we, that would be some things per second. What were the dimensions? We'll find the rate of change of the area, meters,
radius per second.
meters squared per second. Wouldn't be radians because this one here and this one here, the radians would cancel out. So here's your meters, meters squared, and then there was a time on the bottom of that, so it all works out. All right, number 12. We're almost there, huh? Average rate of change in the area of a circle. So now we're going to go plain old pi r squared with respect to its radius as the radius changes from 5 to 6. You guys very slowly now. We're going to have time to do number 10. Ask lots of questions.
So come back to number 1 again. What's that?
Okay, so what do?
Plugging.
Not yet. We want to find the rate of change. Find the average rate of change. So first we have to find the overall rate of change. And it says,
I thought it's
with respect to its radius. So we're going dA, d what? dr. Equals, if I take the derivative of this, I get 2 pi r. And technically, we would go dr, dr. Like we were doing dx, dt, and all that kind of stuff, but dr is just 1, so nobody cares. What?
So is that why I just go with radius? You don't have to-
Yeah,
Right.
because it comes out to be dx, dx, and then this cancels. Yeah. And I always wonder if I should teach that from the very beginning to make the implicit differentiation less confusing, because you're really doing it the whole time, you know, continuing the whole time. Yeah.
I thought, finding average,
Right, but they want the average rate of change, so we do need to find the rate of change.
it is asking instantaneous.
If it wanted to know the instantaneous rate of change, then we would just plug in 5 right here, and then that would be our answer. But since they, oh, I see what you're saying, so we don't even do the, oh, yeah, you're right. Okay. Like has it all figured out. When they do, we don't need to do the derivative because they're doing average rate of change. So this is our x1 and this is our x2. And then now we just need to figure out what the y1 is. So plug 5 in there and you get 25 pi. And then your y2 is 36 pi. Yeah, you're right. So the derivative is only when we're doing instantaneous rate of change. And then how much did it change by? 11 pi?
9 pi.
Is it 11 pi? Am I wrong
9
again?
pi. Oh,
Okay. Got you that time. All right. So 11 pi. And what was the change in the radius over that interval? 1. And so my average rate of change is 11 pi. Well, the area is in, what's our radius given in? Are you just stalling? It doesn't give us any units for the radius, so you want to just pick some?
Oh, okay, so it'd just be a correction.
Right, yeah. Okay. Do you want to pick some units for the radius and then we'll figure it out?
Sure.
Okay, it's because they didn't give us any of the problems. So you want this radius, give me a unit for a radius. Inches, okay. So that's inches and that's inches, which means that this is square inches or inches squared. Okay, So that means that this would be inches squared divided by inches, right? And so one of the inches would cancel and it would be back to inches again. So it would be 11 pi inches. All right, last one.
Oh, yeah.
We're gonna do 1 and 2.
Oh, yeah.
Did we do 1 and 2 yesterday?
I don't know.
Oh, this one.
Okay, so first derivative,
-4 sine.
-4 sine of x. Nope.
Cosine squared?
Nope.
Cosine,
2
Sine of x.
sine of x
Cosine.
cosine of x.
Oh, yeah.
Good. Because you have to think of sine squared of x as being sine of x squared. So you're doing the chain rule. So we did the outside first, which is the exponent, put the exponent in front, and then subtract, and then multiply that by the derivative of the stuff that's inside. Okay? All right, second derivative.
-4 cosine x.
All right, so we gotta go product rule because we have two variables there. So the derivative of the first one is 2 cosine. And the second one, which is this cosine, plus the first one, which is 2 sine, and the derivative of the second one, which is negative sine. And you could leave it like that. Or you could rewrite it as cosine squared and sine squared. Yeah, you can take you can factor out a 2, yeah. So we're good there. Okay? Okay, so the trapezoidal water trough comes out to be extra credit. Okay? Do you guys really need me to go back and do 1 and 2? You're just okay.
Get number 2? Actually, you gotta get number 2 real quick.
I got to get number 2 real quick.
Okay. Just to make sure.
Oh yeah, that was kind of gross. It kind of sick.
You just do the product rule?
Yeah, you have to do the product rule, but you also have to do the chain rule
Okay.
inside the product rule.
Okay, so I think I did. So I'll make it.
All right, so it's the derivative of the first one, right?
3x
3 times 3x plus 1 squared
times 3
times the derivative of the stuff inside, which is 3, times the derivative of the second function, which stays exactly the same, plus the first one
First one is the same.
times the derivative of this one, which is
4 times 6, 4 times square.
yeah.
Oh, yeah.
Okay? And I'm sure you could simplify that out and lots of things would cancel, and the final answer would be like 3x or something, but, you know. What's that?
No.
X to the 4th minus 6 to the 5th power.